Hey everyone, I am Prachi Agarwal from Pranveer Singh Institute of Technology. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week we'll post CodeChef problem explanations, conceptual videos on various programming paradigms, and also conduct live problem-solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great! Now that you have subscribed, let's get started. Today we'll be solving the problem Andrew and the Meatballs, which is an easy problem. So now let us see the agenda. First, we'll try to understand the problem statement, then we'll try to understand what concept we will use to solve this problem, the time complexity, input, output, and constraints, and then we'll code it on the CodeChef IDE. So let's move on to the problem statement. The problem statement says that we have n number of plates, and in each plate there are some meatballs, and that number of meatballs is denoted by P of I. So P of I denotes the number of meatballs that are present on each plate, that is the ith plate out of n number of plates. Now what the problem statement wants us to do is calculate the minimum number of plates that we need so that m number of meatballs can be eaten at least. Now what does at least means? That minimum m number of meatballs we need to eat. And maximum can be any number, but at least minimum m number of meatballs we need to eat. So how do we select these minimum number of plates? Now for that, let us see what approach will come to our mind first. Now suppose that we have an example here. The number of plates are 7 and the least number of meatballs that we need to eat is 16. And this P, this array, it denotes what quantity of meatballs each plate has. So the first plate has 4 meatballs, the second plate has 3 meatballs, third plate has 5 meatballs, and so on. So now suppose if we select each plate one at a time and then add it up. Suppose we selected the first plate first. So we have 4 meatballs with us. Then we selected the second plate. So we have now 3 meatballs with us. Then we selected the third plate. So then 5 meatballs. Then the fourth plate. So we have 1 meatball. And now we will add this up. 4 plus 3, 7, 7 plus 5, 12, 12 plus 1, 13. But 13 is still less than 16. So we have not reached that threshold that we need, like m number of meatballs. So we have still not reached that. So we'll add more plates in this manner only. So now the fifth plate is the one with 9 meatballs. So we'll add 9. So what is 13 plus 9? 22. So now it has become greater than 16. So this totals to amount to 22. Now 22 is greater than 16. So we got our answer that 5 plates at least we need so that minimum m number of meatballs can be eaten. But this is not the minimum number of plates. We need in this question is the minimum number of plates. So instead of doing this, what we can do is simply select the largest plate at each level. So what does that mean? It is written that greedily select the plate with the largest value each time, and then we'll add the number of meatballs on those plates and check if our sum has become greater than or equal to m or not. And if yes, then we'll stop. So let's see how we will do this. So initially this is our array 4351962. Initially this, and the max sum. So in max sum we'll be storing the number of meatballs that we are getting each time by selecting any plate. So now initially from all these plates, the plate with maximum number of meatballs is 9. So we will select 9. 9 meatballs. 9 plus 0 is 9. So maximum has become 9. Now what are we left with? Now we are left with 4, 3, 5, 1, 6 and 2. Now out of this, which one is the maximum? Out of this, the plate with 6 meatballs is maximum. So we have selected 6. So 9 plus 6 is 15. Now 15 is still less than 16. 16, that is the minimum number of meatballs that needs to be eaten. So we'll go on with our with the same concept. Again, now the leftover plates are 4, 3, 5, 1 and 2. Now the maximum out of this is the plate with 5 meatballs. So we'll select 5. Now 15 plus 5 is 20. So 20 is now greater than 16. That is M. So now we know that we need minimum 3 plates to eat at least M number of meatballs. This is how we are going to select the minimum number of plates. Now what was actually happening in this question is that we were each time selecting the largest value from out of the array and adding it to max sum. So first there were n number of plates. Then second time there were n minus 1 plates. Then third time there were n minus 2 plates and so on. So like this only if we go on, then there were n plates, then n minus 1, then n minus 2 up to the point when one number of plates is left. So we need to do the entire calculation, or if we get in between, or if we get the number of if we get our max sum to be greater than or equal to m, then we'll stop in between, otherwise we'll go on up till the very end. So what this is equals to, this is equals to n into n plus 1 by 2. And this is exactly what our time complexity is going to be. So our time complexity is going to be of the order of n square in this approach. Now, is n square an optimal approach? Is there a better approach to do this question? Instead of each time selecting the maximum, then we'll remove the maximum from the array and then again keep repeating it. So definitely there is a better approach to do this. So now let us discuss another approach. Now the second approach is, we will do the same thing essentially. Remember in that approach we were each time selecting the largest value. So instead of just selecting the largest value by going on the entire array each time, what we can do is we can sort the array in a non-increasing order. Now what is a non-increasing order? Non-increasing order is, suppose there are values from A1, A2 up till AN in any array. So a non-increasing order will be if A1 is greater than equals to A2, A2 is greater than equals to A3 up to greater than equals to AN. So this is what is a non-increasing order. And we will sort our array into this order only. And after sorting, what we'll do is we will select each time, starting from the first index, we'll select the elements up till the point where max sum becomes greater than equals to m. So now with the same example, we'll try to do this with the sorting approach. Let us sort this P array. So if we sort this, then we'll get 9, 6, 5, then 4, 3, 2 and 1. This is our sorted sequence of P array. Now all we need to do is select the largest. Now we know if we sort the array, then we know obviously the first one is the largest, then the second one is less than or equal to that. So first we'll select 9. 9 is not greater than or equal to 16. So we'll select 6. Now 9 plus 6 is 15. 15 is again not greater than equal to 16. So again we'll select 5. Now 9 plus 6 plus 5 is 20 and 20 is greater than equals to 16. So we have got our answer. We have selected 3 plates. So the minimum number of plates that we need in order to eat at least M meatballs will be 3. Now we'll discuss the input, output and constraints. The input says that first line of input as it is will be the number of test cases, followed by each line we'll get N and M. So N is the number of plates and M is the least minimum number of meatballs that we need to eat. And what is P? So P is a space separated array of integers which denotes the number of meatballs in each plate. Now output. What will be the output? So the output will be denoting the minimum number of plates, and if it is impossible to take at least M meatballs, then print -1. So yes, the output says that we were finding the minimum number of plates for eating minimum M meatballs. So we'll print the minimum number of plates, and if it is not possible to at least eat M meatballs out of all the plates given to us, then we will directly print -1. So now what are the constraints to this problem? The number of test cases are given to be 7777 and the number of plates are only 7. So the constraints are pretty small in this question. So even if we try to do it with the help of the approach which we discussed earlier, that is the order of n square uh, approach, it had this time complexity. So then also this approach will work, I think, because we have a very small range in the constraints. But now we will discuss the time complexity of our optimal approach, because it is always a good practice to know the optimal approach and do the question by that only. So now we will discuss the time complexity of this approach. It will be order of n log n. How it will be order of n log n? Let us discuss that. For sorting, the time complexity will be order of n log n. So sorting always takes this time complexity. The next operation that we were doing in this approach was we were calculating the sum of all the max elements that were selected. So for sum, it is definitely only order of n linear. So the time complexity together, if we say, it will be order of n log n. And there are t number of test cases. So our total time complexity will be t into order of n log n. This is our total time complexity for the optimal approach. Now, we will discuss some examples so that it is clear how we will get our output. For first example, here n is equals to 4, that is number of plates. P is given to us and each plate has 1, 2, 3, 4 meatballs respectively. And at least we need to eat 7 meatballs. So is that possible? Let us check. We discussed that first we will sort the array which contains the number of meatballs in each plate, that is P. So if we sort this array in non-increasing order, then it will be 4, 3, 2, 1. Now all we need to do is select the maximum element starting from index 0. So at index 0 we have 4. So we will select 4. Now we will check if 4 is greater than equal to m, that is 7. 4 is not greater than equal to 7. So again we will add 3 to it. Now 4 plus 3 is 7. Is 7 greater than equals to 7? So yes, 7 is greater than equals to 7, that is m. So we have got our answer. We need to select only 2 plates. So the answer here is that minimum we need 2 plates, and this will get printed as the answer. Now we will take another example. Now in this example, first we'll sort it into a non-decreasing order. So non-increasing order so first we will sort this into non-increasing order. On sorting we'll get 30, 1 and 1. So this is our array after sorting. Now we will select the maximum value from this starting from index 0. So first we'll select 30 and then check if 30 is greater than equals to m, that is 30 is greater than equals to 33. So no, that is wrong. So again we will add 1 to it. Is 31 greater than equals to 33? No, again wrong. So again we will add 1 to it. Is 32 greater than equals to 33? So no, we are not getting greater than equals to 33. So now the number of plates are finished over. We don't have any more number of plates, and we have still not crossed the threshold that we needed in order to eat at least minimum M meatballs. So in this case, the answer will be -1 because we cannot reach the threshold that we need here. Now we will see one more last example. If suppose we are given only one plate, so the number of meatballs on one plate is 15. So suppose that if M is suppose 16, so if we need to eat 16 meatballs, that is the threshold. So now P is 15 and 15 will always be less than 16. 15 will always be less than 16. So in this case our answer will be -1. But suppose if M was 14 now, or maybe 14 or 15. If M was 14 or 15, then in both the cases our answer will be 1, because it is possible to cross the threshold, because essentially what we are checking is if max sum is greater than equal to M. So if M is 14 or 15, then this condition will be followed and our answer will be 1 in this case. So now I hope that the concept of the entire question is clear to you. Now we'll move on to the coding part on the CodeChef IDE. Okay, so first we will input for the number of test cases. Then we need to input for each test case N, M and P. So we will run a loop from 0 to T, and then we'll input for N and M. So as you know, N and M was given in the form of a space separated integers. So that is why we will use the map function to split it and store it in N and M respectively, that is in different variables, and also map it to integer. Now we will input the array. So in Python, instead of array we have list. That is why I'm using list with map function, because our array is also given in the form of space separated integers that we need to split. So now our array is formed, we have taken all the inputs. Now we will start with our concept. So we will define max sum. You know that it stores the number of meatballs that we have after each iteration. Initially it will be 0. And we will also have one more variable, that is count. So count will keep track of the number of plates that we are using each time. Now here I would like to bring to your notice that in the constraints part, for P and M, all the elements were up to the range of 10 to the power 18. So it is a large number. That is why if you are using C++, then make sure that you define P, M and max sum as long. And if you are using Java, then make sure that you define it as either big decimal, or maybe long can also work, but big decimal would be better if you use that. So now we will run a loop from 0 to N. We know that N is the number of plates. From each plate we need to pick the number of meatballs. But before running a loop, we also need to sort the array. Like we talked about in our explanation, first we will sort this array and in non-increasing order. So for non-increasing order, we will use reverse equals to true inside the function. This will ensure that our array is sorted into non-increasing order. Now after that, inside the loop, what we'll do, in max sum, we will add P of I. So P of I starts, this loop starts with index 0. So what have we added for the first time? We will add P of 0, that is the largest number of meatballs among all the plates that we have. Then second time it will be the second largest number of meatballs that we have. from all the plates. So this way we will keep on adding until we find that if max sum is greater than equals to m, then we need to stop. So now before this condition, we also need to keep a check of the number of plates that we are using, because that is what we need to print. So we will increment the count also. So count, now it is counting the number of plates that we are using. First time 1 plate, second time 2 plates, so and so on. Now this if condition, if max sum becomes greater than equal to m, then what we'll do is we will come out of this loop, because we needed to cross the threshold, and if we do so, then we need not calculate any further. Now after coming out of the loop, again we will check if max sum is greater than equals to m. So if this condition is true, then we will print count. But if this condition is false, then simply we'll print -1. So this is our code, guys. Now let us submit it and check if we are getting an accepted answer. So guys, we have got the correct answer, an accepted answer. We have solved this question. If you enjoyed the video, please like, comment and share, and also give suggestions on which questions we should be picking up next. Also, if you have any doubts or anything that you want to ask, there is a comment section below. Do comment. Please subscribe to our channel to stay notified of the upcoming uploads, and also press the bell icon.